Hello once again. This is teacher Mbaraga Matthew. Previously in lesson 4, uh, we discussed together about the electronic configuration of atoms, and also today we want to see some examples of electronic configuration uh, by starting from these three examples. It says, what is the electronic configuration of number A, potassium, B, sodium, and C, oxygen? So electronic configuration of potassium, which has the atomic number of 19. Atomic number of potassium, it is 19, and atomic number of sodium, it is 11, and atomic number of oxygen, it is 8. So electronic configuration starting from potassium, we can say that we first build the first energy level in this way, and this first energy level, it's a must that it doesn't exceed 2 electrons, which means we will fill 2 electrons. And another thing is that they must be pair for the first shell. They must be pair. They make pair. You don't spread them or split them. You or scatter them. You don't have to scatter them. You have to make them a lone pair, or all a pair. So because we still have electrons to fill, we will continue to build more energy levels. This is the second energy levels. We build it like this. For the second energy level, the maximum electrons to be held in this, they are 8. We don't exceed 8 if they are there. We stop when all the atomic number is presented by electrons. Here we have presented only 2 in 19 electrons of potassium. So which means here we will fill 1. The rule, so the rule is that the law is say that we first fill north, east, south, and west by only single electrons. This is 1, east, 2, south, 3, and the west, 4. If there are 4, we add them to see if we are not exceeding the atomic number of the atom that we are making its electronic configuration. This is 1, 2, 3, 4, 5, 6. With 6 in 19, which means we still have electrons to fill in. You come back and then you start making pairs like this. This is the first pair, the second pair, this is the third pair, and fourth pair in the second energy level, which means here there are 2, 4, 60, 80, and these 2, they are 10. In total, we have installed only 10 electrons in 19 electrons of potassium. So here, which means we have to build another shell or another energy level, because this one is full. It has to hold only 80 electrons. So here we are going to build another. We're going to build another energy level, the third one. So the third one also, these are 10. We first fill north, east, south, and west by using only single electrons. But here we have to be careful. We count to see if we are not going to exceed the number the number given, which is the atomic number of potassium. So here we have the total of 10, which are already installed here, and 10, 11, 12, 13, and 14, which means we still have. That's why we are going to make pairs. 14, 15, 16, 17, and 18. So this third shell or third energy level also, it is now full, which means we can't add anything here. Only what you have to do, it is to create another energy level, the fourth one. We don't exceed 8. Only we can create another energy level. This is how we are going to be successful in our exercise. So here Here they are the total of 18. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, and no. These are 2, 4, 6, 8, 10, 12, 14, 16, and 18, which means in 19 of potassium, we are remaining with only 1, which is not yet installed here. 1 will be here. We'll put here on north, which means now the total, it is 19, which means the electronic configuration of sodium must be like this. So sodium, no, potassium. We are on potassium. So potassium, electronic configuration of potassium, it is 2, you can see, and 8, and 8, and 1. 2, 2, 8, 8, and 1. 2, 8, 8, and 1. So this is the answer of the electronic configuration or electronic configuration of potassium. So if you feel you still need more examples, we will do even these two, but I call you to go and give your own exercise for practicals so that you can make like a chlorine, you can make like a fluorine, you can make a carbon, and so on. So you make sure you make sure you catch up with this basic chemistry of electronic configuration. So let us do the second one. Here you can try the second one. This is the electronic configuration of sodium, which has 11. Let us be quick. 11, we first build the first shell, which will have the pair, and the second one will have 8, and this is the 1, 2, 3, 4, and 5, 6, 7, 8. These are 2 plus 8, they are 10, which means in 11 we are remaining with 1. That's why we will build the third energy level, and we will have remained with 1. This is the electronic configuration of sodium. So which means the sodium, it is equal to electronic configuration, it is equal to 2 and 8 and 1. 2, 8, and 1. So this is the electronic configuration of sodium. Let us continue with the electronic configuration of the third one. It is oxygen. Oxygen, it has the atomic number. Atomic number, it is 8. Atomic number always it is equal to the electrons. If it is electronic configuration, we use atomic number because atomic number always it is equal to the atomic number. It is equal to the electrons when atom is stable, when it did not share any electron. So here we build for oxygen. For oxygen, here we build first one and we'll hold the 2, and the second one will hold the 1, 2, 3, 4, and it has the 8. These are 6. 1, 2, 3, 4, 5, 6. We are remaining by 2. Here we will make this 1. This 6, 7, and the 8. So which means here we have remained with 2 single electrons. 2 single electrons. What I can say is that in the outermost shell, let us see, oxygen is equal to 2 and the 6. So in the outermost shell, or what I can say, it corresponds with the what we call electron valence. Electron valence, they are these electrons which remain single in the outermost shell. It is equal to the valence of an atom always. Here, which means oxygen, it will have the valence of 2. You can go to the lesson number 1. You will see that the family of oxygen, they have 2 electronic valence. It means that when we are doing its electronic configuration, we remain with two single electrons in its outermost shell, where here we have the lone pairs, and this we have another lone pairs, and this is the electron valence, which are 2. Always oxygen, it will be marked by 2 minus. So this 2 minus, this 2, it means this, and this minus, it means the non-metal properties. So we will see the next lesson. It is going to be the electronic configuration of ions. We will talk about that in the next lesson, but here you must know how to do this configuration, electronic configuration, and then after you will see if this has been added with another electron from another atom, for example from a metal, to make ionic compound. What the change if it has added with 2 electrons? Because the electron valence, it means that it is able to receive, if it has a negative sign, it is able to receive another 2 electrons. So here, if it is positive, it means it can give 2 electrons. Oxygen, it receives, which means it will be added with 2 electrons. You make sure if you are doing electronic configuration of this, you have to add if there is negative. If there is a positive, you have to reduce that number of charges. So here, that lesson, it will come in lesson 6. That's what I can say, but it is coming soon. You make sure that you subscribe so that we can be together, and also you ask questions if you have. Another thing is that we have a group of WhatsApp. If you want to join the group, you can let me know, or you can send me a message, and I add you in the group, where you can ask any question, where we share some notes and lessons, and where I share some updates about my lessons of fundamentals of chemistry for the beginners. Thank you so much. I know that if you have any question, you have to ask. If you are not understanding what I have explained here, also you are welcome to ask some questions. Thank you so much.